Good morning all of you. In the last class we have completed the sedimentation process of water treatment, and today we are going to discuss about the next process of treatment of water, that is sedimentation with coagulation. As you know, most of the public water supply projects will are using the surface water as the main source, and this water is turbid and contains many suspended impurities, and they also possess color which may be due to colloidal matter present in water, and these colloids are very fine particles of size 1 nanometer to 100 nanometer, and they carry electrostatic charges. So due to this electrical charge, no two colloidal particles will come together, but they repel each other. Hence, in plain sedimentation process, it is not possible to make the particles come close to each other and settle down as sludge. Therefore, for this purpose, certain chemical compounds known as coagulants are added to the water. Clear? So these coagulants will form a gelatinous precipitate called floc. Clear? Which will then the very fine colloidal particles present in water get attracted and absorbed in these flocs, forming the bigger size flocculated particles. Clear? So next we will discuss about what is the principle of coagulation. So what happens when coagulants are dissolved in water and thoroughly mixed with it? Positive and negative ions are dissipated. The positive ions react with negatively charged colloid particles. These positive ions react with negatively charged colloid particles and will neutralize their charge. So after neutralization of charge, these colloids come close to each other, which process is known as your agglomeration. And these closely packed colloids form lumps or flocs, which is defined as flocculation. So this is the principle behind the coagulation. So next we will discuss about the different types of coagulants. So in general, there are 4 different types of coagulants, such as alum, copperas, chlorinated copperas and sodium aluminate. So first we will discuss about the alum. So alum is the name which is given to aluminum sulfate, and its chemical formula is Al2SO4 18H2O. This alum, when added with raw water, it will react with the bicarbonate alkalinity present in raw water, and this will form a gelatinous precipitate known as your floc. Clear? So this floc will attract other fine particles and suspended matter, that is colloids, and will grow in size, and finally it will settle down to the bottom of the tank. So let us see the chemical equation of alum. So see here, this is the alum. It will react with the bicarbonate, calcium bicarbonate, which is the alkalinity of water, that is the alkalinity which is present in raw water. So this is alum when react with bicarbonate, that is calcium bicarbonate, will form calcium sulfate and aluminium hydroxide. So this aluminium hydroxide is the flock, and it will also liberate carbon dioxide, which will cause corrosion, and this calcium sulfate will impart permanent hardness to water. Clear? And this will settle down. This aluminum hydroxide is the flock, and it will settle, attract other colloidal particles, and will settle down at the bottom of the tank. So this alum is very effective if bicarbonate alkalinity is already present in raw water, and if your water is not having any alkalinity, then you can add some amount of lime to the water. This alum is very effective for the raw water having pH value 6.5 to 8.5, and the dose of alum is varying from 10 to 30 milligram per liter. So this is the dose of alum which we will apply to the raw water. So this will vary from 10 to 30 milligram per liter. So next coagulant is copperas. So this copperas is the name given to ferrous sulfate, and its chemical formula is FeSO4 7H2O. So these copperas are generally added to raw water with lime. So when lime is added fast with copperas, then the following reaction will take place. When copperas will react with lime, then it will form CaSO4, calcium sulfate, and FeOH whole 2, that is your ferrous hydroxide. This one is known as ferrous hydroxide. Okay. So this is the first case. Second case is when coppera is, second one is when coppera is added prior to lime. So when coppera is added to water, then this is the alkali that is present in raw water, that is CaHCO3 whole 2. It will form FeHCO3 whole 2. So after this, when we will add hydrated lime, so this FeHCO3 whole 2 will react with hydrated lime, will again form FeOH whole 2, ferrous hydroxide. So you can see in both the cases, the first case is when coppera is added with lime, so it will form ferrous hydroxide. The second one is when coppera is first added to water and then lime is added to the water, then also it will form ferrous hydroxide. So in the both cases, ferrous hydroxide will form. So this ferrous hydroxide that is formed in either cases will get oxidized, forming ferric hydroxide. So this ferric hydroxide will form the flock and helps in sedimentation. So copperas is extensively used as a coagulant for raw water that are not colored. It is generally cheaper than alum and functions effectively in the pH range of 8.5 and above. For colored raw water, it is however not used as it does not give satisfactory result. And the amount or dose of coppera required is almost same as that of alum. So next we will discuss about the next type of coagulant, that is chlorinated copperas. So when chlorine is added to solution of copperas, the two will react chemically so as to form ferric sulfate and ferric chloride. So this is the copperas, and when it is added with chlorine, they will form ferric sulfate and ferric chloride. So this is the ferric sulfate and this one is ferric chloride. And the resultant combination of the ferric sulfate and ferric chloride is known as chlorinated copperas. So both these constituent of chlorinated copperas, that is ferric sulfate and ferric chloride, when react with lime, they will form, so this is the ferric sulfate. So when this is react with hydrated lime, so they will form ferric hydroxide. Similarly, when ferric chloride also react with lime, it will form ferric hydroxide. So both the constituent of chlorinated copperas along with lime are effective coagulant. Clear? So they will form the ferric hydroxide, which will form it will form the flock and helps in sedimentation. This ferric sulfate is quite effective in the pH range of 4 to 7 and above 9, and ferric chloride is quite effective in the pH range of 3.5 to 6.5 and above 8.5. So this is all about the chlorinated copperas. Next we will discuss about the next coagulant, that is sodium aluminate. So sodium aluminate is also used as a coagulant and its chemical formula is Na2Al2O4. So this chemical, when dissolved and mixed with water, it will react with the salts of calcium and magnesium present in raw water. And this chemical, when dissolved and mixed with water, it will react with salts of calcium and magnesium present in raw water. And it will form calcium and magnesium aluminate. See, for example, if this aluminate is react with calcium bicarbonate, that is the alkalinity in water, so it will form calcium aluminate. Similarly, when this will react with this sodium aluminate is react with calcium chloride, it will also form calcium aluminate. So this calcium aluminate will form the flock. So this coagulant is, the sodium aluminate is costlier than alum and is therefore generally avoided for treating ordinary public supplies. But it is very useful for treating water which do not have the natural desired alkalinity and thus cannot be treated with pure alum. So it is very helpful for those water which cannot be treated with pure alum. And this will reduces the temporary as well as permanent hardness present in raw water supply rather than increasing them. So in case of alum, then it will create or impart permanent hardness to water, but in this case the sodium aluminate will not impart, it will rather reduce your permanent and temporary hardness of raw water supply. So this coagulant is very widely used for treating boiler field waters. Okay, this is very useful for boiler field waters. So this is all about the different types of coagulant. So in the next class we will discuss about the dose of coagulant. Thank you.